Hi, hello everyone. So just do a quick little bit of work here. So what we're going to look at today is some little tricks, I suppose that's the best way to kind of describe them. So here's two scenarios, I suppose, and we're going to have a look at these scenarios. The first scenario is our classical scenario where we've got two circles kissing, basically. So if we were to draw a line between the centers of those two circles, there's a couple of things we can infer. Okay, first of all, and I suppose probably most importantly of all, the distance. The distance between those two centers is R1 plus R2. So the distance is going to be R1 plus R2. The two radii added together will be the distance. A couple other things, because they're only touching one point, any line drawn between that point is a tangent. And of course, we know things about tangents and we can work out little things about it because they'll be perpendicular to the line that's drawn. So on the second one, though, this is probably where it's a little bit more, I suppose the word I'm going to use is a little bit more awkward to kind of understand, but let's take this radius here, okay? That's the radius of this smaller circle, okay? And let's take this radius here and try, and I'm going to try and draw the bit of it that you can see is going to be in black. The rest of it will be hidden under the green one, if that makes sense to you. I hope it does make sense to you. Okay. So this radius lies underneath the green radius. So this is radius 1 and this is radius 2. Remember, radius 2, that's the length of radius 2, if you know what I mean. It's a big one. Most of it's hidden under the green one. Well, in this case, the distance between that center and that center is just going to be radius 2 minus radius 1. In other words, the bigger radii minus the smaller radii is going to be equal to the distance between the two centers. Okay, and of course that helps you figure out some things. What does it help you figure out? First of all, it'll help you figure out without drawing it whether they're kissing on the inside or kissing on the outside. In other words, if you have an how would you determine whether one circle is internal to the other? Well, if you find the two radii taken away, then find the distance between the two centers. They should be equal to each other. Whereas in this case, if they're kissing externally, then if you find the two radii and add them, it should be equal to the distance between the two centers. Okay, so again, this is going to use your skills like, can I work out what the distance is between two centers? In other words, can I actually read off the centers of a circle, that type of thing. So listen, we'll try a few of these just to kind of get you into the flow of it. They're not too taxing, these ones, but again, they're just more like, so let's just put down two equations. X squared plus y squared minus 2x minus 15 equal to 0. And here's another one. Let's call that circle 1. And circle 2 is x squared plus y squared minus 14x minus 16y plus 77 equal to 0. Okay, so what we're going to do is show that these are kissing each other. So if they're kissing each other, then the distance is going to be equal to R1 plus R2. Distance between the centers is R1 plus R2. So that's what we have to prove. Okay, so we'll start by getting the very basics one. Let's find the distance. Okay, so how do we find the distance? We find the distance by getting the centers. Okay, how do we find the centers? Well, it's half the x and y coefficients and change the signs. So half of minus 2 is 1, changed signs as a positive 1. There's no y value. So circle 1 has a center equal to 1 and 0. Circle 2 has a center equal to 7 and 8. Okay, So I've got that information. Now it would be handy if I got the radii. Okay, the radius of 1 is going to be the square root of 1 squared plus 0 squared plus 15. Okay, the radius of 2 is going to be the square root of minus 7 squared plus minus 8 squared minus 77. So let's get those radii then. That's 4. That's 49 plus, that's 6. Okay, so all I need to do now is get the distance between them. Distance, x1, y1, x2, y2. Square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. That's 10. So it's 10. My rule is the distance, 10 should be equal to 4 plus 6 QED. It is. Okay, and you're done. So there's a nice little starter one just to kind of get you going on that one. Okay, so we will try another one. We will try another one because that's what they're there to be done with. And let us try, we'll try one where we have to prove that they're inside. Okay, so let's try this one then. Okay, so circle 1 is x squared plus y squared minus 4x minus 6y plus 5. And circle 2 is going to be x squared plus y squared minus 6x minus 8y plus 23. I want you to show me that this is the situation. In other words, distance is equal to r2 minus r1. In other words, big radius minus small radius. Okay, so I'll do a 3, 2, 1 pause, and you're going to give this one a go yourself. 3, 2, 1 pause. Nice. Here we go. So same thing again. Let's get the center of 1 is going to be 2 and 3. The center of 2 is going to be 3 and 4. 4. And the radius of 1 and the radius of 2. Radius of 1 is going to be the square root of whatever, minus 2 squared plus minus 3 squared minus 5. Radius of 2 is going to be minus 3 squared plus 4 squared minus 23. So this is, what's that? 4 plus 9 is 13. 4 and 9 are 13 minus 5. 13 minus 5 is 8. So that's root 8, which is 2 root 2. And this is going to be 9 plus 4. 9 plus 16 is 25 is root 2. So we just need to get the square root of x1, y1, x2, y2. x2 minus x1 is going to be root 2, I bet you. Plus, yeah. So in this case, d is root 2, should be equal to 2 root 2 minus root 2. And would you believe it is? Okay, so it's an insidey. Coolya. Right, so there's a bit of fun. Some very nice ones. Nothing too kind of taxing. Okay. Again, stuff you should be well able to do. So let's try another one then. Let's get a bit more technical, as the man says. Okay. So let's take a circle with a center of 2 and 3 and a radius of 4. Now, first thing I want you to do, we're going to sketch this. So what does sketch mean? Sketch means, you do your best. Okay, there's an XY axis. Let's say 2 and 3. There's the center. So it's going to be something around about there. Okay, I'm not going to be 2. Okay, radius of 4. Okay, and 2 and 3. So it's something like that. Okay. Now, let's try and figure out some things about it. Let's try and figure out that let me see. Yeah, here's a nice one. Show that the distance between the the points it cuts the y-axis is 4 root 3. Okay, we have to figure out that. Okay. And then we need to find, right, let's start with that one. Show that the distance between the points that it cuts the y-axis at. So in other words, the distance between those 2 points is 4 root 3. Okay, so how are we going to do it? Well, listen, a couple of ways you can do it. You can generate the equation. Okay, once you've generated the equation, let x equal to 0, solve for y, and get your 2 y points. Simple as that. That's an easy enough way of doing it. And then once you've got your 2 y points, take one from the other, and you should get 4 root 3. Okay, that's one way of doing it. Okay, so let's give that one a go. And then we might show you a kind of a more mature way of doing it. Okay, for want of a better word. So we're going to do our usual. We're going to do a 3, 2, 1 and a go, go, go on this one. And you give it your best shot. Okay? 3, 2, 2, 1, go, go, go. So here we go. How are we going to do it? What have we got here? We've got x minus 2 to be squared plus y minus 3 to be squared is equal to r squared. So if I let x equal to 0, oh, listen, the reality is, if I let x equal to 0, I can expand this out to get my general formula, but is there any point when I'm going to, that's all good, you know what that's going to become anyway, like, it's not going to be too tough. So if I let x equal to 0, that's going to be minus 2 squared, which is 4, plus square the left, square the right, multiply them together and double it, bring that over. Okay, so what are we going to be left with here? Got a y squared minus a 6y, and we've got 30 minus 3. Okay, so that's y squared plus 6y minus 3. That doesn't look like it's going to come out nicely. We're going to do a minus b on this one, but then that makes sense because if you look at the answer, look at the given to us here at the start anyway. So we were going to have to do something about that. Okay, so let's have a gander. I'm going to get this on the old calculator because life's too short. So we're solving, aren't we? Menu 2, 2. So we've got a 1, a 6, and a minus 3. So we've got a minus 3 plus 2 root 3. And then what's the other one? Minus 3 minus 2 root 3. So there's our 2 possible y values. Okay, so there are 2 possible y values. You just need to take one from the other. I don't know which one is the bigger one. Minus 3. That one looks like the bigger one, so I'll take that one from that one. Okay, it's going to be fun. Let's see, do I get it? Well, minus 3 minus 3 plus 3, which is 0, and then you have 2 root 3 and 2 root 3, which is 4 root 3. I don't even have to do this, do I? Okay, so what have we got? We've got minus 3 plus 2 root 3 minus 3 minus 2 root 3. So minus 3 plus 3, so that's gone, and then 2 root 3, and that's going to be a positive root 3 because that negative, that's 4 root 3, which is what we were told it was going to be. Okay, so there you have a nice little one done for you. Don't know how exciting that is for you, but that's how it's done. Okay, so that's where it cuts the y-axis. Okay, not very exciting, but I suppose it is what it is. You could do the same thing again, find where it cuts the x-axis, do the same whole show. I could see why people might expand it out into the general form before doing it, because that's where you've been doing it before now, but I don't personally see a reason and a need to be doing that. Okay, to me, it just seems a little bit, pointless. All right. Okay. Right. We'll try one more. Let's find another one. I'm just trying to find ones that are particularly cool. Okay, here's a nice one. Okay. Right. Circle 1 has a center of 4, 2 and makes a chord 6 units long on the y-axis. Find the equation of C1. So, what do we know? We know that it must make a chord 6 units long on the y-axis. So I don't know what it looks like, but I do know the following has to be true. The center of 4, 2 is out here somewhere. I know it has to cut the y-axis there, and the distance between them is 6 units. So that's the only information I have. Okay? Now, it's not much, but it is something. So the question is, can I glean? The only thing I really need from this, I need to find the radius. Okay? So here's my suggestion for you. Okay? So you have to go with me on this one. Okay? What do we know for sure? We know that if this is 6 units and this is a chord, then a perpendicular bisector drawn from the chord to the center bisects the chord. We did this earlier on, which means that this side is 3 and this side is 3. Okay? I know the distance from there to the y-axis is going to be whatever, 4, because x is 4. So you can see what I'm building here. That means that this third side of this triangle, which I know now to be a right angle triangle because it's a perpendicular bisector, has to be the radius. So let's call this r. So r squared is equal to 3 squared plus 4 squared. R is equal to the square root of 3 plus 4 squared, which is 5. So now suddenly I have it. So let's put it all together. What do we got? The diddly idle do. X minus 4 plus y minus 2 is equal to 25. Now, isn't that a nice one? Okay. That's a nice little one. So what we've done today is we've had a good look at 3 new methods of kind of looking at these, what I call kissing circles. Okay. If they're kissing on the externally, then the two centers, the distance between those two centers is equal to R1 plus R2. If they're internally kissing, then the distance between the two centers is the bigger one minus the smaller, bigger radius minus the smaller. Okay, so just be careful of that one. Okay, it's the bigger radius minus the smaller if they're kissing internally. So that's a test for them. If you know no information, there's a test to see which one of them is without having to draw them. So remember, you're not going to have time to draw them. Okay. Other thing we've kind of picked up on today is if you see a surd in the distance, if they give you a surd, there's a chance you're going to have to do a minus b formula. But listen, you know, you're comfortable enough doing that yourselves. At least you should be. Okay. Otherwise, apart from that, you've got most of it kind of like it's the type of question that if it comes up, it's very doable because there's lots of ammunition you can throw at it in terms of all your little tricks. Okay, even if you never knew that, you'd figure it out. You would figure it out. It would make sense to you to do it. Okay, where I could see this becoming hard is if they throw some type of algebra into it. But again, they won't throw algebra unless there's a way out of it, unless there's some access point to get you back out of that algebra. Okay, so that's probably the key thing to take away from that. You really need to have a kind of an access point into it, and that could be a substitution, it could be an angle, it could be something else that's just thrown in there to kind of show you a way out one way or the other. Okay, remember your Pythagorean triplets, you know, for your like 3, 4, 5, that can get those things done pretty easily. Right, well listen, we leave it at there. Hope that helped you a little bit. Thank you very much.